Well, good morning, everyone. Hopefully you're having a good week, and I want to thank you for joining us this morning. And today we're actually going to be discussing pre-startup and safety review on our road to continuous improvement. So really, what we've done thus far is we've actually went through those first few elements. First, we talked about management systems and who is supposed to do what, and who is responsible, who is accountable, who's to be consulted, and who's to be informed on the different various parts of our management system as it pertains to process safety. We've also talked about employee participation. We've talked about process safety information and the three different elements that are contained within process safety information, including information about the hazards of the chemicals, information on the technology of the process, and then information pertaining to all of the equipment that we have as well. Then we went in and discussed the PHA, or the process hazards analysis, and we also talked about the importance of making sure all of your process safety information, or PSI, is correct and up to date prior to conducting that. We talked about operating procedures, training, and then contractors was last week, or actually a couple of weeks ago, or last month. Today we're going to be talking about pre-startup safety reviews. Before we kind of get started into this, if you have any questions as we go along, feel free to put it in the Q&A portion of this here webinar, and we'll address those at the end today. Sometimes I address those during the actual webinar itself, but today I want to take them at the end because this webinar is fairly short, because Pssr only has a few elements. Doesn't mean that it's any less important than any of the others. It just means that there are just fewer things to address as part of your Pssr. So let's talk about the actual regulation first. It says the employer shall perform a pre-startup safety review for new facilities and for modified facilities when the modification is significant enough to require a change in the process safety information. I think that's key to this, this particular element, is any change that involves any change to your PSI, your process safety information, should result in a Pssr being completed. Also, a pre-startup safety review shall confirm that prior to the introduction of highly hazardous chemicals to the process, these four things are addressed. Construction equipment is in accordance with design specifications. Safety and operating maintenance and emergency procedures are in place and adequate. And then for new facilities, the process hazard analysis has been performed, or recommendations have been resolved or implemented before the startup. And then, of course, training for each employee involved in operating a process must be completed as well. Those are the main ideas behind the process pre-startup and safety review, and making sure that those things are actually completed. So really, what's the intent and purpose of this particular element? It's first to ensure the process is ready to start up. And believe it or not, there are many processes that get started up before they're actually ready to. We get in a hurry to start those processes up, and we don't go through all of those checks and balances before we actually introduce chemicals. Those type of processes can lead to some pretty catastrophic events, and have in the past. We want to make sure that the installation is as designed. In other words, was it installed as it was designed, or were there modifications actually made to that process as they went along, and those weren't documented? Pssr should check those and find those and address each of those. The other thing is that the design is well documented. All the PSI is in place for the entire process. The PHA has been addressed. In other words, if there was a need to conduct a process hazards analysis, that was completed. If there was not a need to conduct the PHA, then was there some type of hazard assessment conducted of some sort prior to startup? Ensuring that the written procedures have been developed. And then, of course, training on operations and operating procedures has been conducted as well. It's to also ensure the process equipment is installed and all tests and checks have been conducted. A lot of times this is where things go wrong. A lot of times what we should have and what we should see in our SOPs is initial startup. This is kind of where it's covered in the Pssr as well. So we're wanting to make sure that those initial startup procedures are in place. A lot of times those initial startup procedures entail those initial checks, those initial tests that need to be performed prior to adding those chemicals, making sure all of the interlocks work, making sure all of the alarms work and the set points and everything else are correct. In some cases, depending on your process, sometimes that's a water batching, where you actually run water through the process rather than the chemicals to make sure everything works correctly. Not in all processes can you do that. For ammonia refrigeration, for example, you can't go through and water batch the process, but you can make sure that it's pumped down and make sure that all of the oxygen or air is removed, all the non-condensables are removed in the system. That means pulling a vacuum for a certain period of time to make sure that all of the moisture has been removed as well. And then, of course, it's also it's a final opportunity to address any startup issues, making sure that we're looking at all of the things within the startup to make sure that we've addressed making sure that we have enough people on hand to do that startup, making sure that we have safety equipment that's standing by, et cetera, depending on the process that you're starting up. So when is the Pssr required? Well, it's required when there's a change being made to existing processes or any facility being added to an existing process or facility. So if you're making any change to an existing process or you're adding a new process, obviously that's going to be changing your PSI, your process safety information. So therefore a Pssr must be completed. Any other activity that a facility designates as needing a pre-startup safety review, and we'll talk about those here in just a second as well. It's temporary changes. You know, a lot of facilities have temporary management of change procedures that they can make temporary changes to their process. A Pssr should be conducted prior to adding chemicals for even those temporary changes, both before and after. What I mean by that is before you actually add chemical, and if you're reverting back to the way it was before, then you should be doing a Pssr after it's completed as well to make sure everything was returned back to the way it was prior to that change. And if not, then you're going to have to initiate perhaps a permanent MOC to correct those changes. Also, restart up of idle processes. A lot of facilities will idle equipment, maybe during the summer or the winter, et cetera. When they're restarting that equipment back up, you must and should go through a Pssr to make sure that everything's in place prior to that. Restart up of a system that's undergone overhaul or significant maintenance. For example, there's a lot of facilities that have compressors and major equipment that get shut down and overhauled. You should do a Pssr when you complete those tasks and before you start that equipment up to make sure that everything was done, everything was returned back to normal. Perhaps you even have to go through initial startup procedures again to check everything to make sure that it works, including your alarms, your interlocks, and all of those things that could have been affected during that shutdown. Of course, a restart after a shutdown or turnaround is always a great idea, especially in chemical plants, refineries, and gas plants, et cetera. A lot of times during these turnarounds and shutdowns, for example, relief valves are blocked in, lockout tagout is done, and sometimes those relief valves don't always get lined up correctly and car sealed open or those valves car sealed in the correct positions. So a Pssr is a good idea after a major turnaround and shutdown. They really provide us a second layer of protection and to also help us to manage changes, and that's really what the intent is. So here's some of the gaps that we see quite often, and we're up now close to 280 compliance audits that we've done probably in the last 8 to 10 years. And we track that information to kind of see, are we actually improving? Are our industries improving in their knowledge and understanding of PSM, but also understand the intent of it and understand how we can get better at process safety by doing the things that are outlined in the PSM regulations themselves. So we track that information. We're trying to understand where the gaps are. And when it comes to PSSR, what we're seeing is there's no PSSR completed. For 62% of the audits that we do, we find issues where PSSR is not completed. And when we say PSSR not completed, we're strictly looking at changes to the PSI or changes to operating procedures themselves. So we're not looking at other things in addition to that. For example, we talked about doing a PSSR after major turnaround, et cetera. We're not looking at those things. We're just looking at what the regulation is required, the requirements of the regulation itself. Again, we're seeing 62% of all of the audits we're finding there was no PSSR done at all. Action items from PHAs not completed. And this really has to do with changes to the process or new changes or new processes that were added where the PHA is required and all of the action items are required to be completed prior to the introduction of chemicals. 84% of the time we find that those action items are not completed. 37% of the time we see operating procedures that are not updated or completed for a change that required a PSSR. 58% of the time we see mechanical integrity procedures not updated or even completed. 74% of the time we see spare parts not addressed. A lot of times when a change involves process safety information, maybe it's a model number, maybe it's a different type of piece of equipment that's being used. Your company's probably set up spare parts for that equipment. Now those spare parts are sitting idle that don't have any equipment that they're tied to. Secondly, you have the potential now for your process to be shut down for an extended period of time because you don't have those spare parts set up. And it could be also potential for exposing employees to those hazardous chemicals as well. 63% of the time we see training on new procedures or changes not completed at all. So a lot of times what we see in facilities, they'll do an MOC. For example, they'll write the MOC, they'll make the change, and the only requirement that they have that would indicate that training was done is that the operators are expected to acknowledge the change. Acknowledging a change is not the same as training on a change. So we want to make sure that we're actually training our operators and our engineers and our operations folks themselves on the change and how does that affect them? How do they operate it differently? What can they see that's different? And making sure that our procedures reflect that. A lot of times our operating limits are reflected in some of those changes as well. And some of those consequences of deviation and steps to avoid need to be changed as part of that change as well. That's the whole idea behind the PSSR, to make sure that those things have actually been addressed and employees understand and operations understands what to expect if something goes wrong. 9% of the time we see employees not informed of the change at all. So a lot of times what will happen is maybe an engineer, and I'll have to raise my hand here. I'm an engineer myself, so I've been involved in some of these in my past life. And so a lot of times the engineer will make a change and not tell anybody about that change. Maybe it's just a change in a set point. Maybe it's a change in an interlock or a change in how a process would normally respond to a out of limits consequence. If that's the case, still operations need to be trained and understand that change so that they're aware of when they see something different, how to respond. So some of the best practices for PSSR is really to kind of look at some of the industry process safety related incidents reports. Try to get an understanding as we read some of these reports, whether it's through the CSB, through the CCPS, and there's a number of different agencies that even API, for example, has different incident reporting entities that you can actually look at some of those incident reports. Unfortunately, there's no way to look at them all in one combined place. I wish there was, because we can learn a lot from others that have had issues and incidents in their facilities, and then we can apply those learnings to some of ours. But that's what the PSSR should be doing as well, is those of us who do have access to some of those incident reports, we can start updating our PSSR documentation to ensure that we're looking at these things as we're doing those final checks before adding chemicals. The other thing that I always tell people is a lot of times what will happen is the engineer is the one that's in charge of a change. Let's say the engineer or the lead operators in charge of a change, and they're also the ones that do the PSSR. A lot of times what happens is that engineer will say, yeah, it's good enough, I've got it where it needs to be. But if somebody else looks at does the PSSR rather than the actual person that's in charge of making the change, then you do a much better job of making sure that everything is done and done correctly. That's why I tell everybody, always select a team leader that's removed from the specific project. And then, of course, involve others in the PSSR process. And that includes your operators, maybe some of your management, et cetera, getting them involved. And that's all, again, part of your employee participation plan and putting it in practice. Also is use electronic data systems for capturing PSSR documentation. I have seen PSSRs that have been 50 to 60 pages long, and going through that whole process becomes difficult. So if you make it electronic and make it easier, then it becomes a much less laborious process to conduct that PSSR, and it's more likely that it's going to get done. Also, as we talked about earlier, perform that PSSR on critical maintenance activities. When you're doing those shutdowns, or when you're doing a startup after a major overhaul of a piece of equipment, do those PSSRs. You're going to learn from that. You should learn from that. And in the process, we should update our management systems and evaluate performance based on that systems. And what I mean performance-wise is performance of our PSM program. Is our program really working? And that's where the PSSR really can help. I can tell in all of the audits that I do where they have a robust PSSR program in place, they have less issues when it comes to PSI being incorrect, less issues on hazardous hazards that they've identified in PHAs. They have less incidents. They have less, not necessarily less near misses, but certainly they have a high level of knowledge of what's going on in those near misses. So having a robust and really a well-detailed PSSR is going to help you in a lot of ways. So the next steps really in addressing all of those gaps that we talked about earlier is I tell people all the time, develop a robust or evergreen PSSR checklist. There's a lot of checklists that we can develop, but PSSR is really a good one. Categorize that checklist. So make it where it's simple. If I have a change that involves just a policy on employee participation, there's no sense of doing a whole checklist and reading through a whole checklist for PSI, PHA, and SOP, et cetera. We can focus on just the areas that we need to focus on. That goes back to what we'll talk about here in a couple of more months when we talk about the management of change and how we can link those two together to make sure that we're making it easier. We should always be auditing our PSSR process for an eye for things that should have been done, but were not, and trying to understand why they were not done. If we're really being open and honest during our audit process, we should be looking for the reasons why things don't get done. Not that they didn't get done. Yeah, that's important, but what's even more important is understanding the reasons why they weren't done. When we start understanding the reasons, then we'll start making changes to our management systems and our program to address those issues. Make doing a PSSR simple and easy. If you have to fill out 50 pages of checklist, that is not simple and easy. And I guarantee you that after time, they'll stop getting done. Again, so if you combine these two, make it electronic, make it where it's focused on the actual change that's taken place, then it becomes easier to do. Yes, there are going to be instances where you may have to fill out all 50 pages of that PSSR. Usually that's going to be on fairly large projects that entail all different parts of PSM. But make it easy for them to do. Again, if there's more people involved in that PSSR process other than just the process engineer or project manager, getting other people involved, then that process becomes simpler and easier as well. Make PSSRs important. And what I mean by that is don't look at PSSR as, well, that's something I have to do before I can actually add chemical. Make it the most important part of that whole process as you're going along. Let's say if you start out with just a simple change, a management change, that's step one. But then there's a whole bunch of other stuff that has to happen in between. You have to develop the PSI, you have to develop all the process design, et cetera, all the SOPs. The last thing we do is a PSSR. So we make that the most important thing and make sure that we're checking all of those things specifically to make sure that they're done. The next thing we want to do is create a KPI or key process indicator that measures performance of actually just this particular element, making sure that all of the checklists were filled out, making sure that everything was addressed, and more importantly, maybe looking at what things are missed. As we're going through the PSSR, we may find things that are getting missed all the time. And if we're finding those things, then it's time for us to go back to our management system, our RACI, and make sure that somebody's responsible and accountable for making sure that those things get done. Continuous improvement, and remember, failure to update the process safety information can relate back to, several failures of your PSM program. Can be failure of your taking care of your process hazards analysis, making sure that you understand and document all of your PSI. For example, here's one we come across quite often, is we know that relief systems, for example, require a design basis. Many times we'll see the design of the relief valve itself, in other words, how it was actually designed, what scenario was actually used for designing the relief device, but we don't always get to see the basis. If the basis was not there, how do we know whether or not the design is correct or not? So we need to make sure that we understand, and our engineers and our engineering companies that we may use, our EPCs that we may use, understand that we need to have full documentation of not only the design, but also the basis for that design. All goes into that process safety information that we need to attain continuous improvement. So I'm going to just kind of recap, and then I'm going to answer any questions that you have here too. I just want to kind of recap of what we've done thus far. We've talked about the first group of PSM elements, and mainly we talked about employee participation, et cetera. And these are part of what I call the design process. So for those of you that have been involved in the design of a process, that kind of the steps that we kind of go through, that we develop the team, the design team. So that design team can be made up of operations. It can be made up of engineers from different roles, electrical engineers, process engineers, mechanical engineers, et cetera. We also have operations folks that help us from the standpoint of perhaps developing operating procedures. they've been involved in operating processes before, so they should be on those process teams. So that's all part of employee participation. We know that through the design process, we develop all of the specifications for all of the equipment and the process itself. We do the PHA, we develop the SOPs and safe work practices. We do all of the training. Typically, contractors are involved in installing these processes and equipment. And then the last thing that we talked about today is the Pssr. So we make sure that everything that we said we were going to do, we're actually doing through that Pssr. These are the main things that happen through a design process. Now that we have this process designed, it's started up. We said at the end of that Pssr, we're ready to start this process up. We're adding chemicals. Now the process is actually running. Now what we want to be able to do is maintain that equipment to those original design specifications. And now we're going to add the next elements. And those are the next elements are mechanical integrity. They're hot work. Eventually we're going to have to replace pipe. We're going to have to replace something. So typically hot work is going to be involved in that process. We also have a change management system, or the MOC, that we'll use to make sure we're managing any changes that we make to that PSI and any changes that we make to those procedures, et cetera, that we just talked about. If we're doing a good job of investigating any incidents, if we have any incidents, and including those near misses, then we're going to make sure that we make those changes to the process to make it even safer. So an incident investigation typically is going to involve a management of change process, and we're going to change something to make that process design better so that we don't have those incidents in the future. We also have emergency response, emergency action plans. That's all part of the maintaining that system. Obviously, if we have a good response system and action plan, we can minimize any effects on employees, but also may minimize the effects to our equipment and process as well. And then the last thing is the compliance audit. Is that final loop to kind of make sure that all of these things are being done the way that we said that they would be through our management systems, et cetera. One of the things we always have to keep in mind is you can only maintain what you know. So if our process safety information and all this other information that we've talked about for the last few months is not correct and it's not up to date, then we'll probably not do a very good job of maintaining it because we don't know what we don't know, right? So knowledge is the key to process safety and continuous improvement. The more knowledge that we have of our systems and documentation is obviously knowledge, but also more knowledge we have of process safety in general through our management systems, et cetera, the better we will be at process safety. So now, if you have any questions, feel free to put them in the question box and I will answer them here in a second, okay? So I do have one question that I'm going to repeat right now. It says, is a change like for like? Is the change like for like, is it required to do a Pssr? Can you give advice to someone that new to the industry with minimal knowledge of PSM, RMP? Well, first of all, if it's like for like, most likely it would not require a Pssr. However, there are some caveats to that. And I'll give you a good example. So let's say, and we first of all, we have to go back to the definitions. We covered definitions on the first webinar that we did on our road to continuous improvement. The definition of a change is as long as it makes, a like for like change would be as long as it meets the design specification, right? So that means a lot of different things to a lot of different people. First of all, if I have a motor, for example, a 50 horsepower motor, I'm replacing the motor with another 50 horsepower motor. The only difference is the brand name. So it went from a Ram to a GE type motor. Same specification, still 50 horsepower, all of the electrical information is the same, met all the design specifications. Now, most would say that that's a like for like, and I would probably agree with you that it's a like for like. Should we do a PSSR? If you're asking me, I would say yes, and here's the reason why. Even though it's a like for like, it may not require an MOC per se. If you're doing condition monitoring, what I mean by that is vibration analysis, et cetera, then we know that that each motor manufacturer uses different parts, et cetera, and those parts have different frequencies, and those frequencies are related to condition monitoring. So if I'm doing condition monitoring, maybe I want to do a PSSR to get my person that does my condition monitoring to come back in and do a baseline reading, a vibration reading on that motor. Or if I'm installing and I have condition monitoring equipment, then you're going to see a change in that data, and you want to make sure that you document that change really took place. So a lot of facilities will do an MOC, whether it's like for like or not. Now, just to answer this question here, you know, theoretically, no, it would not require a PSSR because there was no change in PSI, correct? But on the other hand, it may be something you want to address. So any other questions? I'll wait here a few minutes, and if you have some questions, feel free to ask those. So if we have any more, don't have any more questions, I just want to invite you to come back next time. We're going to start with mechanical integrity. What we may do is break this one down into two different parts. Since mechanical integrity is a pretty important element within PSM, we're going to really focus on some of the key aspects of mechanical integrity. So we may divide this one up into two parts. I may focus mainly on the first webinar, just talking in general about mechanical integrity. And then looking beyond that, we're going to look at things like how we address PHA safeguards. For example, those items that we identified within our PHA, for example, interlocks, maybe alarms, and maybe some other elements within there that we need to make sure that are part of our mechanical integrity. Some would call that critical equipment, et cetera. So we're going to look at that aspect of mechanical integrity and apply it to our mechanical integrity element. So if you have no more questions, thank you for attending today. And we look forward to you talking to you, I think, next month regarding mechanical integrity. Everybody have a great day. I'll stay on for a few more minutes to take any questions and can certainly answer those if you have any. Thank you.